This is the second in a series of videos on Times Microwave's new Silverline test cable product line. The first issue I'd like to address is the problem customers report about connectors breaking off the cables too soon. For a good high-performance RF cable, the connectors need to be soldered to the outer braids. In the example here, you can see that the body of the connector has been soldered to the braids of the cable. When you do this, the solder wicks up the braids and creates an area that's stiff or inflexible. This is an example of a failed solder joint. The body of the connector has been soldered to the cable braids, and with repeated flexure, the braids break. This is a very classic problem. All manufacturers fight this same issue. How do you solder the connector to the braids but still give the customer a product that is flexible and long life? Times has addressed this issue with a novel approach to connector design. This is an example of our new SMA. It's a three-piece design. I'll just take it apart. The front of the body is made separately. There's a separate solder ferrule and a long tail or back nut. The solder ferrule is soldered to the cable, much like the direct solder method. But that's where the similarity ends. At that point, the cable is inserted into the long tail, and the delicate solder area is now nestled in the steel sleeve. The front of the connector is finished with a captive contact center pin. Loctite is applied to the threads, and the front of the body is torqued on. In this fashion, the delicate solder area, the area that fails so quickly, is now completely and permanently encased and is immune from damage from flex or twist. After the connector is completely assembled, we need to add a strain relief system to transition from an area that's stationary or immovable to an area that needs to be flexed. Many companies do this by adding a molded strain relief boot. The problem with a strain relief boot is many times it does not match the flexibility of the cable. What Times did was it chose 3 separate strain relief sleeves. These are inner meltable wall sleeve systems with a glue on each one. Each one of these has been chosen for its degree of flexibility. The first sleeve goes all the way up to the end of the connector, and the subsequent sleeves do as well. And what this does is it provides a perfect transition from an area that needs to be rigid or immovable to an area that needs constant flexing. This system is actually more time-consuming and more labor-intensive, but it has proven to be extremely rugged and durable. It also eliminates any torque or twist from being introduced into the cable. Here's an example of the Type N with the strain relief boots in place. Now I'd like to show you how we address this issue with armored cables. Many customers require longer cables, and the possibility exists that the cables could be damaged from pressure, from a cart, from stepping on the cables, and other forces. Times uses a high flex life PVC with a stainless steel spring embedded in the PVC. The tail, as described earlier, is drilled into the armor in a reverse fashion. The reverse torque opens the spring as the tail is pushed in. When the torque is taken off of the tail, the spring returns to its former position and clamps down on the tail. In this way, as you pull outwards on the tail, the spring actually becomes tighter. This end shows the finished product, but prior to the boot system being added. There's a long and large crimp ferrule that is crimped over the armor, and it crushes and pinches the stainless steel spring between the crimp ferrule and the tail inside. The finished product, with the strain relief boots applied, looks like this. A cable so armored with this booting system will exhibit in excess of 175 pounds of pull force on the connector.